Okay, so what we're looking at in 3 is instead of having the 6-sided, we had the 4-sided, right? So the sample space, we look up at our example here. The sample space is going to be our brackets, and then what are we going to have inside?
1, 2, 3, 4.
1, 2, 3, and 4. Okay. Now, you use the sample space to answer your questions, right? So, the first one, what's the probability that you will roll a 2?
1 out of 4.
There is only one face that has the 2, so that would be 1 out of 4. Okay. Your second one, the probability that the number is at least 2.
3/4.
What's the...
P is greater.
What's the symbol? Tell me the symbol again. Greater than or equal.
Oh, that's what, yeah. That wouldn't make any sense. Greater than or less than.
It just kind of saves you having to write it out.
My words.
I mean, it wouldn't be wrong, but... And that's how many of the sides?
3/4.
It's 3 of them, right? So 3/4. Your next one, a number greater than 4.
0.
What would be our symbol?
Oh, less than, greater than.
Greater than, is the 4 included?
No.
No. So how many of those do we have?
0.
We have 0. So 0 out of 4, which simplified
0.
is 0. And then our last one, the probability that it is
Greater than 0.
greater than 0. How many of those faces are greater than 0?
1.
1?
Oh, it equals to 1.
Yeah, okay. So what's the, we're going to start with what? How many of the faces?
There's 4.
4. 4 out of 4, which gives us our 1. Okay, so let's see what we had. What was the smallest number we had?
0.
The smallest number. That it's your 0. Okay. What's your largest number?
1.
1. What'd you have in between?
1/4 and 3/4.
You had a 1/4 and you had a 3/4. All right. So again, can 1/4 be written as a decimal?
Yes.
And can it be written as a percent?
Yes.
Yes. Can the 3/4 be written as a decimal?
Yes.
And a percent? Yes. Okay. So let's take a look at the next page. All right. So, if an event can never happen, did we just have an event that did not happen?
Yeah.
Yes. And its probability was what?
0.
0. If an event can never happen. Didn't we just have that one? What was the one we got 0 on? A number greater than 4. We didn't have any numbers greater than 4, right? No.
No.
Sorry. Wrong page. Yeah, greater than 4. That's right. And so the probability of that event is our 0. If an event is sure to happen, which one was sure to happen?
The 4.
The greater than, were they all greater than 0?
Yeah.
Right, so that was our 1. Okay. And then what did we have in between? We had a 1/4 and we had a 3/4. Okay. So this is probability. So probability is going to hit between 0 and 1. If there is no possibility, you will actually hit the 0. If all of your list of your sample space, if all of them will hit, that's a sure outcome, and that is your 1. Okay? So that's where your probability hits. Questions on that? All right, let's do 4 through 8. Okay, in probability, what is the word or phrase for the set of all possible outcomes? That's your sample space.
It's not writing.
Oh, yeah.
What? It's not?
It's not doing the thing.
Well,
Oh, there it is.
okay. like I don't know how to fix that if it's not. Okay, that's your sample space. Okay, let's skip 5. Let's go to 6. What is the smallest possible value for a probability? 0. What is the largest possible value of probability? 1. Okay. All right. If a student is chosen at random from your class today, what is the probability that the student selected is a male? How many do we have in here today?
11, 21.
No, how many students? 21, and how many of them were male?
11.
I think it's 11. My goodness. Okay, now let's go back to 5 real quick, and then we'll kind of talk about this. You guys pretty much approached it the same way my other 2 sections approached it. You guys said, well, it's kind of a 50-50. It either, if it's not one, it's kind of the other, right? So that's kind of what we're going to see here in a minute as we finish up. All right, so let's move on to the next page. Okay, now what we have is we have the contestants for the Springboard Superstar Contest.
Wait, what?
I'm sure that's what you all want to be, right? Y'all want to be some contestants for the Springboard, Superhero Springboard, or whatever it is? No. All right. Okay, so now you're going to be doing the same thing, but you have a different set of data, right? Kind of different, okay? So, before you get started, let's look at 9A. What is the sample space for this? What would you put for sample space on this one? The ages? 12. If you used 12, are you going to be able to answer the probability of Casey? No. What would your sample space have to look like to answer this one? No, if you just saw 1, 2, 3, 4, 5, would you see Casey? No. So what's your sample space?
Do we put the ages? The age range?
You could, but what else? But that still wouldn't answer Casey. What's the only thing that's going to you're going to be able to? Does gender answer Casey? Age is not going to do that. The names. Yes, thank you. Yes. Okay. So
What did you see?
your sample set would be the list of all the names, right? So I'm going to give you a pass on that, okay? You can just right there on your paper say it is the list of names, okay? And then you have the list in front of you that you will use to answer your questions, okay? All right, so I'll give you a few minutes. What's the probability that the contestant will be Casey? Yeah, how many Caseys are there? There is only 1, so that's 1 out of 12. What's the probability that the contestant will be a female? How many females do we have? 6 out of 12, which would be? As a percent would be? 50%. Has a last name beginning with Z?
0.
So 0 out of 12 is? 0. So that's the low, right? On our little scale. Is under 30 years old?
12 out of 12.
It's all of them.
1.
Or 1. Has a last name beginning with B? 3 out of 4. Okay? Doesn't.
9.
Oh, no, okay, wait. Before you, yeah, hold up. The 3, what'd you get?
3.
Not 3 out of 4. You,
3 12.
yeah, hold on. Okay.
2 1 4.
It was 3 out of 12, wasn't it? All right. Okay, that doesn't.
9 out of 12.
9 out of 12. What's the connection between those two probabilities?
Add together. 1.
We add them together, they're going to be what? 1, right? That's in answer to question C, right? So, when you're given a situation like this, would those two always add up to 1?
No. Yes.
What-
I mean, I said, why did I put no? I meant yes. Yes, it will always add
Yeah,
up to
it's
1.
always going to happen because if you have does and then you have doesn't, and you're very specific, in this case they were very specific, starting with the letter B. Are you going to engulf the entire sample space? Are you going to include everything in your entire sample space if you add those two probabilities together? Yeah, you are. You are catching the one is so if you said did, then you've got those, but the rest of them are not. Okay? So this kind of goes back to that question 5. You guys were kind of thinking, well, it's a 50-50. You either have one or the other. This is kind of that thinking here. Okay? So if I say specifically they have a first name that begins with S, and then they have a first name that doesn't begin with S, is that always going to encompass that sample space? Because you're covering all the odds in that case.
I wrote no, but I meant.
Yeah. Okay? So, next page. Those are what we call complements. Okay? Those last two that you did, those are called complements. Okay? And that is the probability that an event does not happen will be the entire set minus what? Minus the probability that it does. Okay? So those are referred to as complements. Okay? When I was looking over at Armando, he had gotten one of those numbers wrong. He went back and corrected it, and you know what he automatically did? He corrected the second one because he could already see that that was going to happen, and it was going to happen every time. So good job on that.
Good job, Armando.
Okay, now, what are we doing? Okay, let's take a look at our last problem here. Here we have Jenna and James, and they were recently married, and they've decided that they want to have 3 children. Okay? So they've got some time on their hands, I guess, and so they're just going to sit there, and they're going to figure out, well, what are those combinations of girls and boys that we can get? Okay?
Who takes the time?
Okay, from our sample set, the probability that the family will have 3 girls. That's only going to happen how many times? Yeah, it's only going to happen that one. Oopsie. No, it's only going to happen all girls, so 1 out of 8. Exactly 2 girls. Okay, so you got 2 girls here, 2 girls here. Where's the other one? Right here. So 3 out of 8. At least 2 girls. So what are they doing on that one? They're just, yeah, this is going to be the 4, right? So the 4 out of 8. Or 1/2. Okay. Now, C. What is the probability that they will not have exactly 2 girls in the family? So let's go back to 2 girls. 2 girls was right here. So if it's 3 out of 8, not is going to be
5.
And what's going to happen when you add those 2 together? You're going to get what? 1. Okay. Questions on that? All right.